Number 7, solve this inequality. Great tour. So we think, oh, this is an OR. However, we must realize, wait a second, that guy has a negative on that side. This is a special case. So I'm not going to be going through everything like I normally do of setting it greater than the positive piece and negative piece and all this and that. I've got to think, hey, this is a special case. I know an absolute value always comes out to be positive. No matter what, that guy's going to be a +1, +2. He's going to be positive. How often does that answer, which is going to be positive, how often is that greater than -3? How often is a positive number bigger than -3? Always. That means no matter what you plug in for n, it's going to work. Every real number will work no matter what you plug in. Check it out. Plug in 6. 6 minus 8 is -2, but the absolute value of a -2 is what? Well, right up there is a +2, and +2 is bigger than -3. So the solution number 7 we must realize is all real numbers. If this had been going the other way, a positive number is never smaller than -3, then nobody would have worked. Hopefully you recall that. All right, interval notation, nice and simple. Start, end. Starts at 7, ends at 9. How do we say it? It includes 9, we put a bracket. Does not include 7, so we put a parenthesis. That's how interval notation works. This one, interval notation. Now this is x smaller than 3, so it's all numbers less than 3. If you think of a number line, if you need to, here's 3. We're saying all x is smaller than 3. Everybody, smaller numbers are to the left, aren't they? Yeah. So where does this start? Because the first number has to be where it starts. Far left, where does it start? Starts at -infinity and ends here at 3. It includes 3, so we put a bracket. You can never include infinity nor -infinity because they're concepts, they're ideas. They are not literally numbers. So we always put a parenthesis for those.